Welcome to lecture number 46 of Fuzzy Sets, Logic and Systems and Applications. In this lecture, we are going to discuss the contrast, intensification and orthogonality. And this lecture is in continuation to our previous lecture, which was on linguistic hedges, where we have learnt the concentration and dilation of fuzzy sets. So, since we are going to discuss the contrast intensification in this lecture, and we have already the idea of the concentration of a fuzzy set. So here, in contrast intensification, we use the concentration of fuzzy sets. So let us assume that we have a fuzzy set A, and this is nothing but this fuzzy set A is a linguistic. This fuzzy set is for a linguistic value. So in other words, we can say we have a linguistic value, and which is characterized by a fuzzy set. And if it is a continuous fuzzy set, then we have mu x here as the membership function, mu x as the membership function. And if we have a discrete fuzzy set, which is just the representation of linguistic value, then the mu ax is the membership value. And of course, this membership value is basically the corresponding to the generic variable x. So the contrast intensification is basically represented by INT, which is, you can see here, INT is the symbol for the intensification, the contrast intensification. So we have A. If we have A as a fuzzy set which whose intensification is needed, or whose contrast intensification is needed to be done, then we write this as the int of A. So we normally write this int of the normal bracket, the small bracket here. And this is represented by, this is expressed by the int of A is equal to, it is 2A, and then you see A raised to the power 2 within bracket. This means that we are doing the concentration, and this concentration is a normal concentration, because for normal concentration we have K is equal to 2. So here we have the intensification of A. This will be equal to 2 into A raised to the power 2 within the bracket. It means we are concentrating the fuzzy set A, or in other words, I can say the A is being normally concentrated, so that we have K is equal to 2. So A raised to the power within the bracket 2, and then whatever comes here as we multiply it by 2. So this is for the membership value. This computation is for the membership value. So let us now understand this. This is true for mu A of x is greater than or equal to 0, or less than or equal to 0.5. And this, of course, is for all x, for every x belonging into the universe of discourse, capital X. And then we have another expression. This is valid for mu A is greater than or equal to 0.5 or less than or equal to 1 for every x belonging into capital X. And if this is the case, then we have another expression. What is this expression? We have the negation of 2 into negation again of A whole raised to the power 2 within the bracket. So this needs to be completely understood, that we apply this intensification in two zones. So first zone starts with below 0.5 and the second zone starts above 0.5. So above 0.5 as the membership value, we have 2 into A raised to the power within the bracket 2, and below 0.5 as the membership value of A holds the value of the intensified membership, negation of 2 of negation A whole raised to the power within the bracket 2, which is clearly written here. You can understand by this expression. So the intensification is very, very important concept, and this is used for the reducing the I'm writing here for reducing the fuzziness. So whenever we intensify, we do contrast intensification of any linguistic value which is characterized by a fuzzy set, we essentially do the reduction of fuzziness which is present in the fuzzy set. So you can just see here, this paragraph mentions the same. That means that the contrast intensification INT increases the value of mu A of x, which are above 0.5, and diminishes, means reduces, those which are below this point, means the 0.5 as the membership value of fuzzy set A or the linguistic value A. Thus, the contrast intensification has the effect of reducing the fuzziness of the linguistic value A. The inverse operator of the contrast intensifier is also available, is also used, and this is called the contrast diminisher, which is represented by dim, D-I-M, which is, as already mentioned, that it is the opposite of the contrast intensification. So let us have one example of a discrete fuzzy set to understand the contrast intensification better. So here we are taking this example where we have a fuzzy set A, which is of course a linguistic value, and this is with the universe of discourse which is defined here, and the universe of discourse here we have 1, 2, 3, 4 and 5. So if we see here that we have a fuzzy set which is a discrete fuzzy set which is available with us, and this represents a linguistic value, And if we are interested in finding the contrast intensification or the int of A, then let us see how we can manage to get. So as I have already mentioned that we first look for the point where we have to apply the first expression that I mentioned, that above 0.5 as the membership value and below 0.5 as the membership value. So if we look at this fuzzy set where we have these two, you see here these two terms. So 0.7/1, 0.6/2, both are above 0.5. And so here the expression for contrast intensification that we'll be using is nothing but the 2 into A raised to the power within the bracket 2. Means we are going to concentrating the fuzzy set, and then we'll the membership value that we have for this fuzzy set, we'll multiply this membership value by 2. Similarly, we have one term here which is with 0.5. So this 0.5, now the question comes which expression we should apply, because both the expression are applicable. So whatever expression that we apply, both are going to give the same result, because both are applicable for the 0.5 as the membership value. So now here we see that we have these two terms which are below 0.5. So these are below 0.5. These are below 0.5 as the membership value. And here these are above 0.5 as the membership value. So this way we see that we can clearly apply the expression which are valid for these membership, for computing these membership value for intensification of A. So let us quickly go ahead and see how we proceed. So for x is equal to 1, we have mu A of 1, which is 0.7, and this is within this range. So this is above 0.7. So this expression applies. What is this expression? Expression here that applies is the negation 2 into negation A raised to the power within the bracket 2. So when we compute, we are going to get the new membership value, which is 0.82 for the generic variable 1. Similarly, for x is equal to 2, that is mu A of 2, which was given as 0.6. So here, and now since this is 0.6, so it is very clear that the 0.6 is lying within this range where mu A is more than or equal to 0.5 or less than or equal to 1. So this way, when we apply the expression of int contrast intensification, we get 0.68/2. here 2 is the generic variable value, that is x is equal to 2. Similarly, for x is equal to 2, the same can be computed, and this, please remember that this membership value for the generic variable 3, for the generic variable value 3, which is 0.1, so it is clearly understood that this membership value, since it is below 0.5, so the contrast intensification expression will change, and the contrast intensification basically here will be 2a raised to the power 2 into a raised to power within the bracket 2 is equal to 2 into 0.1 raised to the power 2, means the new value that comes out to be here is 0.02 for 3. So similarly, for x is equal to 3, we can compute, and we see that we are getting for generic variable value 4.5, and similarly for generic variable value 5, we are getting the membership value of the contrast intensified fuzzy set as 0.185. So this is how we get a new fuzzy set. So please remember that this is how we get a new fuzzy set, which is the intensified fuzzy set. This is called contrast intensification of fuzzy set, and when we apply these expressions as I just discussed, and for these two conditions, and when we compute these new membership values, new membership grades for respective membership, for respective generic variable values, so this way we get all these computed, and then when we write the new fuzzy set, which is nothing but the intensified fuzzy set, which is the contrast intensification of A, and this is nothing but since we have already computed all these new membership values of respective generic variable values 1, 2, 3 and 4, so we get this new fuzzy set. So this is the intensified fuzzy set. Or in other words, we can say the intensified, or we can say the intensification of a fuzzy set A. So that's how we managed to get the contrast intensification of a fuzzy set that was given to us. Now let us take another example, and this example is for the continuous fuzzy set. So if we have a fuzzy set A, which is a continuous fuzzy set, if we have a fuzzy set A, which is a continuous fuzzy set, see here we have a fuzzy set which is a continuous fuzzy set. Continuous fuzzy set. So, and if we look at this fuzzy set, this fuzzy set is characterized by a membership function, and this membership function is mu a of x, and mu a of x here is a triangular membership function. So I can write here a triangular membership function. This is represented by the triangle of x semicolon 1, 3, 5. And we all know that is 1, 3, 5, 1, 3, 7 are the vertices of the triangle that we are intending to are intending to use for to represent the membership function. So here we have a triangular membership function, which is a triangular membership function, and the vertices are 1, 3, 7. We can see here the same membership function, and this membership function is for fuzzy set A. So this is a membership function which is characterizing a fuzzy set A. Now let us use the contrast intensification function int for this fuzzy set, and we can use this formula, this expression for contrast intensification and this is going to give us a new fuzzy set, which is the intensified fuzzy set, which is contrast intensified fuzzy set, and we'll look as to how this fuzzy set is. We'll see as to how this fuzzy set looks like. So as this intensification function, the contrast intensification function is applicable, and this intensification function has two expressions, and the first expression is applicable in the first zone, and the second intensification function expression is applicable for the second zone. So first zone is basically the zone which is below the 0.5 membership value. So this is the first zone. I write here the first zone, and then we have the second zone, which is applicable to more than 0.5 as the membership value. So now and please understand that any membership value which is exactly equal to 0.5, so please understand that both of them means either of these expressions can be applied. And of course any of these if you apply, both of these are going to give the same value of the intensified value of the membership function of the intensified fuzzy set. So let us now see what is happening. So when we apply this for the first time, so for the first time means we apply the intensification function here, the contrast intensification function. So when we do that, we see that below 0.5 line, this is below 0.5 line, this mu is equal to, I can write here, is mu of A is equal to 0.5. So below this in zone 1, the fuzziness is getting reduced because you see the membership values of the corresponding generic variables are getting reduced. And when we talk of the zone 2, here the zone 2, so in zone 2 we see that the membership values of the intensified fuzzy set A is increased as compared to the original membership value of the fuzzy set A for corresponding generic variable values. So this way we have, when we apply this contrast intensification for continuous fuzzy set, when we plot the intensified the contrast intensified. I can write here intensified fuzzy set. So the fuzzy set that was given to us was A, and when we intensify, this will look like this. So this is shown by a red color fuzzy set. So now when we have found another fuzzy set, which is the intensified fuzzy set, I can write here a intensified fuzzy set, let's say B. If it is B, if it is represented by, let's say, B fuzzy set, so this is B, and now we can further intensify this fuzzy set, and let's see what happens. So now when we further go for the contrast intensification of fuzzy set B, let's see how it looks like. So intensification once again is going to give us, if this is B, then we let's represent this by C, the new fuzzy set. So intensification is going to give us, you see here, the new fuzzy set is represented by fuzzy set C, and which is shown by yellow color. See here. So this was the so this new fuzzy set C is compared to the fuzzy set B. This is B fuzzy set, the red color fuzzy set B, as I have already mentioned. So this is B. So I can write here that B and C both B and C both have reduced fuzziness as compared to the fuzzy set A. So fuzziness can be, by taking the intensification, by taking the contrast intensification, the fuzzy set gets reduced. When we go further, let's say this fuzzy set is a D fuzzy set. Intensification once again. So if we represent this fuzzy set by a violet color, which is D, so this is further intensified, and we can clearly see that this the 0.5 line is the separator. Below this, the behavior is different, and the above this line, the behavior is different. Means below this line, whatever membership values are there, it is getting reduced. Above 0.5 line, the membership values are getting increased. So this way we are able to intensify the membership value. With this, I would like to stop here, and in the next lecture we'll continue with the orthogonality of fuzzy sets. Thank you.